Hi students, this is Viswanath, chemistry faculty for NEET and IIT exams. In today's class, we will learn general organic chemistry. In this, electronic effects. In organic chemistry, organic compounds are react with one another to form products. Now, what is the reactivity of organic compounds? That means how these organic compounds react in a chemical reaction to form products, and what are the effects influencing the reactivity of organic compounds we will learn. Now there are some effects are there to influence the reactivity of organic compounds. Before going to that, we will learn a new terms. Reactants react with one another and form products. In these reactants, two terms are there. One is substrate. Substrate means a substance is being attacked. Substance is being attacked is called substrate. And reagent means substance which attacks other substance, other substance is called reagent. So substrate means substance is being attacked, and reagent means substance which attacks other one is called reagent. In a chemical reaction, this reagent attacks this substrate and form products. Now see the electronic effects which are related to reactivity of organic compounds. First one is inductive effect. Inductive effect. See this. A carbon chain containing halogen at one end. A carbon chain having chlorine at one end. Between carbon and chlorine, covalent bond is there. Between these carbon atoms also, covalent bond is present. Now consider this covalent bond. It is a polar covalent bond. This is polar covalent bond. Polar covalent bond. And this one is a non-polar covalent bond. Non-polar covalent bond. Non-polar covalent bond means a covalent bond is formed between two similar atoms is called non-polar covalent bond. Here no charges are developed on the bonding atoms because both the atoms belong to the same element. That's why this type of covalent bond is called non-polar covalent bond. Whereas polar covalent bond means covalent bond is formed between two different atoms, between atoms of the two different elements having electronegativity difference. Between the atoms of two elements having electronegativity difference, a covalent bond is present, that is called polar covalent bond. In this case, between carbon and chlorine, polar covalent bond is present because chlorine is more electronegative than carbon. Due to this, bonding electron pair is more closer to the chlorine atom, then partial negative charge is developed on the chlorine. Consequently, partial positive charge is developed on this carbon. Now, due to more electronegativity of chlorine, bonding electrons, that means sigma bonded electrons are more closer to the chlorine. Partial negative charge on the chlorine atom, then partial positive charge on the carbon atom are developed. Now, this positively charged carbon atom attracts sigma bonded electrons from adjacent carbon atom. Then partial positive charge is developed on this carbon atom. This carbon atom attracts sigma bonded electron from the adjacent carbon atom, then partial positive charge is developed on this carbon. In this way, partial displacement of sigma electrons takes place in the organic compound, either due to electron withdrawing group or electron releasing group. In this example, chlorine is a electron withdrawing group. That's why displacement of sigma electrons takes place towards it. In some other compounds, due to electron releasing group, displacement of sigma electrons takes place. This type of effect is called inductive effect. So inductive effect means a permanent and partial displacement of sigma electrons due to electron releasing or electron withdrawing groups is called inductive effect. This inductive effect is represented by the symbol I. Inductive effect is represented by the symbol I. Now, this inductive effect we cannot observe in case of alkanes. What is meant by alkanes? Between carbon atoms, only single bonds are present. Those are called alkanes. See this? This type of bonding is present in the alkanes. So, in alkanes, between same atoms, single bond is present. So, there is no polarity. Charge developing is not observed in case of alkanes. That's why inductive effect we cannot observe. Now, see the characteristics of inductive effect. First one is it arises due to electronegativity difference. It arises due to electronegativity difference. Between the bonding atoms, electronegativity difference is there. Then we can observe this inductive effect. Next, second one, it operates through sigma electrons only. It operates through sigma electrons only and do not participate pi electrons. Pi electrons do not involve. Pi electrons do not involve or interfere. Only sigma electrons participate in this inductive effect. Next one is it is distance dependent effect. That means after 3 carbon atoms, this effect vanishes. After 3 carbon atoms, this effect disappears. Up to 3 carbon atom only, we can observe this effect in the given compound. Next, it is represented by this type of symbol. Okay, see this? Here also, electrons displacement takes place towards in this direction. That's why this type of arrow mark. And next one, it is a additive property, additive effect. It is a additive effect. It is a additive. It is a additive effect. Additive effect means it is related to direction. In which direction inductive effect is developed. So based on the direction, we can get a resultant inductive effect. For example, say this one, this compound CH2Cl2, dichloromethane. In this dichloromethane, arrangement of atoms are in this way. Chlorine. So between carbon and chlorine, polar covalent bond is there. Chlorine is more electronegative than carbon. That's why partial negative charge developed on the chlorine, partial positive charge is developed on the carbon. Then displacement of sigma electrons takes place towards chlorine. Here also in this way. Okay. So in this way, this covalent bond, polar covalent bond having some inductive effect, it has some inductive effect. Based on this resultant inductive effect we can get. In this way, inductive effect is a additive effect. That means it is related to direction. Next, types of inductive effect. That means this inductive effect is classified into two types. One is plus I effect. Another one is minus I effect. Minus I effect. Plus I effect means electron releasing groups are present in the organic compound. We can observe plus I effect. Minus I effect means electron withdrawing groups. EWG, electron withdrawing groups. Electron releasing groups means, example, alkyl groups. Alkyl groups are electron releasing groups. They exhibit plus I effect in the given compound. Say this one. Electron releasing alkyl groups means CH3. CH3, methyl, ethyl, and propyl. These type of alkyl groups exhibit plus I effect. They release electrons to the attached carbon atom. In these type of groups, CH3, how many carbon atoms? One carbon atom is there. Ethyl means CH3, CH2. Two carbon atoms are present. C3H7 means three carbon atoms. CH3, CH2, CH2. Three carbon atoms are present. Number of carbon atoms present in the chain, then positive inductive effect increases. Number of carbon atoms increases in the chain, then positive inductive effect increases. Here also same thing. For this less plus I effect, more plus I effect than this one. For this more plus I effect than these two. And another case is number of carbon atoms are same, but arrangement is different. Arrangement means primary carbon atom, secondary, tertiary. Then what is the order of plus I effect means? Say this one. CH3, CH2, 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 butyl. This is primary. And same carbon atoms we can write in this way also. So this is secondary. And another one, CH3. This is tertiary. So primary, secondary, tertiary. In these three types of carbon atoms, tertiary carbon atom having more plus I effect than secondary than primary. So this is the order of plus I effect. Order of plus I effect for different types of carbon atoms having same number. So number of carbon atoms are same in all these three cases, but arrangement is different. So tertiary carbon atom having more plus I effect than secondary, which is more plus I effect than primary. Okay students, we'll meet you in the next class.